This is going to be questions 14 through 20 of the mock EOC study guide. These are the last 7 questions that you need to complete to be prepared for the mock EOC we're taking this week. So, question 14, identify the correct graph of the polynomial function. We're given f of x equals x plus 1 multiplied by x plus 2 multiplied by x minus 2. This skill comes from section 3, topic 7 through 8. And even though we don't know how to graph a cubic function, which is what this is because we have 3 x's, we can use what we've learned to identify the key parts of this function. So here I'm looking at x plus 1, x plus 2, and x minus 2. So if I use the zero product property rule, if I set x plus 1 equal to 0, I know that x is equal to negative 1. So that will be one of my y-intercepts. Same thing for x plus 2. If I set that equal to 0, then I'm going to have x is equal to negative 2. That's a second y-intercept. Then I have x minus 2, set that equal to 0, and I have x is equal to a positive 2. These here are my x-intercepts, my solutions, my zeros. So let's look at the graphs that we were given, A, B, C, and D, and I have to zoom out in order to look at them all, and see which ones have x-intercepts of negative 1, negative 2, and a positive 2. So negative 1, negative 1, negative 1, okay. X equals negative 2. Well, here I have a negative 2. Here I have a negative 2, negative 2, and negative 2. And then finally, x equals 2. So that's our third x-intercept that we're looking for. X equals 2, x equals 2, x equals 2. That says x equals 1. So just by looking at my x-intercepts, I can cross out C and I can cross out D. So I'm left with A and B. Well, with A, I have a y-intercept here is equal to negative 4. Here, my y-intercept is equal to a positive 4. Well, how can you find the y-intercept of this function? Well, remember that to find your y-intercept, that's when your x is equal to 0. So all I have to do is plug in 0 every time I have an x in this function and find what my y-intercept is. So if I plug in 0 for x and I add 1, 0 for x and I add 2, 0 for x and I subtract 2. So I'm going to have 1 multiplied by 2 multiplied by negative 2. Well, 1 times 2 is 2. 2 times negative 2 is equal to a negative 4. So that is equal to my y-intercept. And so if my y-intercept is negative 4, that means my solution, my correct answer here is A. Because in letter B, my y-intercept was positive 4, which is incorrect. Okay? Moving on to question 15. Which graph represents f of x equals negative 1/2 multiplied by x minus 2 squared plus 1? This is section 6, topics 4 through 7. So this is what we did right before break. They gave us this function in vertex form. And if we have a function that's in vertex form, meaning we have our h and our k, and if we have an h, k, we know that our hk here is going to be 2, 1. So that's our vertex. Will be at 2, 1. Okay, so here my vertex is at 2, 1. Well, here my vertex is at negative 2, 1. So I can cross that out. This vertex is at negative 2, negative 1. So I can cross that out. And then I have a vertex of 2, 1 here. So already I knocked out 2 possible solutions just by looking at my vertex and pulling out my vertex from this function. Now this is, now I'm going to look at my a term. Okay, my a term here is equal to a negative 1/2. Well, a negative a term means that my parabola is opening down, and a 1/2 parabola would mean that that function is compressed and not stretched. But the other thing that we can look at here is our y-intercept. Okay, because our y-intercept for here is equal to negative 7, and my y-intercept here is equal to negative 1. Well, how can I figure out what my y-intercept is? The same thing I did before. I'm going to get rid of that x and I'm going to plug in 0 instead. So that's going to be negative 1/2 multiplied by 0 minus 2 squared plus 1. Well, negative 2 squared is 4. If I multiply that by a negative 1/2, negative 1/2 times 4 is going to be a negative 2 plus 1 is equal to a negative 1. So my y-intercept is equal to negative 1. So that means that my only possible solution is A, because D's y-intercept of negative 7 is not correct for this function. Okay, some key things you need to remember going into the EOC. The mock EOC and the EOC you're going to take in about a month or two is how to use the skills we've learned this year to identify key parts of a graph. Okay, let's look at question 16. Yay, I can zoom in a little bit more now. Okay, question 16 says the following information is given about values L, M, N, and P. Okay, so we have L is equal to the square root of 10, M is equal to the square root of 1, N is equal to the square root of 11, and P is equal to the square root of 25. Which of the following expressions results in an irrational number? Select all that apply. Okay, this is from section 1, topic 5. And if you have been in my class all year, you remember us talking about when you add irrational numbers or when you multiply irrational times irrational and all those types of rules. So this is what they're asking about in this particular problem. So what we're going to do is we're going to first look at L, the square root of 10. Well, the square root of 10 is an irrational number because it is not a perfect square. M, the square root of 1, Well, the square root of 1 is equal to 1, so that is a rational number. The square root of 11, again, that is not a perfect square, so that is an irrational number as well. And then we have the square root of 25. Well, the square root of 25 is 5 plus or minus 5, if we remember. So I added that to the 1. So plus or minus 5 is also a rational number. So which of the following expressions results in an irrational number? Well, if I have m, which is rational, and I'm adding it to p, which is also rational, I'm going to get a rational number. So that is not an irrational number, so I would not select it. L, that's an irrational number. I'm going to add that to m, which is a rational number. Anytime I add irrational to a rational, I'm going to get an irrational number. So B is an answer. C, N, which is irrational, plus L, which is also irrational. If I'm adding two irrational numbers, then I will still have an irrational number. So I will circle that. P plus L. So P is a rational number because it is plus or minus 5. L is an irrational number. Well, anytime I have a rational plus an irrational, I am going to get an irrational number. So with this style of question, two things to look out for. Are they asking for rational or irrational? So make sure you're looking at what they're asking for. And if they have select all that apply, it will always be more than one. So you always have to select more than one, but never all. That goes for the EOC. You will never select all of the answers. Always more than one, so at least two, but never all. Okay, question 17. The table below shows the speed of northbound cars and southbound cars on I-4. Create a set of box plots that represents the given data correctly. So if we look at this, they want us to create a box plot that shows the northbound cars and the southbound cars and the speed that they are going based on the data. So the first thing we have to do is we have to take this data and we have to organize it. So we're going to first look at our northbound cars, and we're going to look for our lowest number, our lowest speed. Excuse me. Which here is 60. Then I'm going to look through my sets of data and look for my next speed. After 60, I have, that guy must have been going really slow, 65. And I have 65 again. Then I have 67. Then I have 68. 69. And 69. Then I have 73. 74. Okay, said 74 and wrote 75, so 74. Then I have 75. Oh, look at that. I forgot a 68. So I'm going to write 75 in there, 74 in here. And your data does have to be in order. If your data is not in order, then when you split your data to create the box plot, you will have created it incorrectly. All right, So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So I have 11 data points. Well, to find my median for a box plot, I need to go right in the middle of this data. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and I'm at 68. So I have 1, 2, 3, 4, 5 on both sides, 1, 2, 3, 4, 5 on both sides. So my median is 68. And I can label that median. That's the middle of my data. Now I need to break apart my lower half and my upper half. Well, I have 5 data points in my lower half. Middle of 5 is going to be 65, and the middle of my upper half will be 73. So that will create my IQR, my interquartile range. So now I have the data that I need to graph my northbound box plot. So I'm going to go up here to 60 because that's my lowest. And I'm going to go to 68, estimate about right here. And then 73, estimate about right here. Oh, 65. All right. And then my maximum is at 75 right here. Okay, so my median, you'll see, is right there, about 68. And then my interquartile range, my IQR, falls between in that box. And then I have my whiskers, which go all the way out to my lowest data point and my highest data point, which is 75. Okay, now I'm going to look at my southbound data. And I need to organize my southbound data just like I did before. So my lowest speed for my southbound data is 55. Then I have 59. Hopefully I don't make a mistake in this one. Then I have 60. Then I have 61. 62. And 63. 64. 67. 68. 71. And 72. Okay, again, I have 11 data points, just like I did before. My median is going to be 63 for this set of data. My Q2 is going to be 60, and my Q3 is going to be 68. So now I can use that data to graph my second box plot. So here, my median, sorry, trying to scroll up. Here, my median is 63. Okay, my Q1 is at 60, and my lowest point is 55. My Q3 is 68, which is going to be right at the median for my other box plot. And then my highest value for 70 is 72, which I can estimate is right there. All right, now I've taken a set of data and compared the two of them with using box plots, and I can determine that the cars going northbound have a much higher median, so an average speed, which is higher than the southbound cars, where their median speed is at 63. All right, question 18. Given the set of data, what would be the best measure of center and measure of spread. So looking at this data, we have symmetrical data. This is symmetrical. Okay, but we have also an outlier. And this outlier is going to affect that data. Okay, if we have an outlier, that means that our mean will increase because of that outlier. And if our mean is going to increase, so will our standard deviation. Okay, so if we have an outlier, both our mean and standard deviation are going to be affected. However, if you have an outlier, your interquartile range and your median stay the same. So your I want to write this in. Your IQR, your interquartile range, is the same, and your median also stays the same because they are not affected by an outlier. So if we have an outlier, the best measure of center and the best measure of spread are going to be your median and your interquartile range. Now, if you have symmetrical data without an outlier, then you could use your mean or in standard deviation. But anytime you have an outlier, you have to make sure that you're using your IQR and your median for your measure of center and your measure of spread. Okay, we have just 2 more questions. Question 19 comes from section 10, topics 1 through 3. Okay, Ms. Shishagwe surveyed her students about their preference of math, reading, and science. The table below shows the results. So in question 19, our first step is to identify the percentage of the boys and their preferred subject. So here we want to compare the data for the boys and their preferred subject. And we're just going to write this in the box. Okay. So what we do is we take that 70 and we have to divide it by the total number of boys surveyed, which is 150, and 70 divided by 150 is equal to 47%. Okay? Then we're going to take the boys' data for reading, which is 50, and we're going to divide that by 150. So 50 over 150, and that is equal to 33%. Then finally, we're going to have 30 divided by 150, and that is equal to 20%. Okay, so we identified the percentages for the boys and their preference. Step B, identify the percentage of the girls and their preferred subject. Okay, so now we're going to take 47, divide by 100. Well, that's going to equal 47%. 33 divided by 100, and that's equal to 33%. And then 20 divided by 100 is equal to 20%. Is there evidence that a greater percentage of boys prefer math than girls? Well, if we're looking at just the percentages, is there evidence that more boys prefer math than girls? No. The percentages are the same. So there's no evidence that more boys prefer math to girls because you're not looking at the numbers, you're looking at the percentage of the students surveyed to determine that. And the evidence shows that they are the same because we're looking at percentages and not just numbers. So that would be no. Okay, question number 20. Which equation represents the line of best fit for the data shown? Okay, remember for our line of best fit, you're going to try your best to imagine or draw a line through the data perfectly. That line of best fit should have an equal number of dots on both the left and the right when you draw that line. So we need to figure out the equation for this line of fit. So when we're figuring out or matching an equation, we care about two things, the slope and the y-intercept, which is b. Our b term here needs to be a positive 3. So immediately looking at options A, B, C, and D, I can cross out A and I can cross out B because the y-intercepts of 1 and 4 are not correct for the line of best fit. So now I need to look at my slope. Is my slope closer to 3 or 2? To find your slope, remember that's your rise divided by your run. So to determine my rise, I'm going to try my best to find a point that comes close to intersecting. So I like this point right here at 3. And I'm going to go up 2. So my rise is 2, and I'm going over 1. So my slope is 2 over 1, which is just equal to 2. So my answer here would be D.